Hello everyone. First of all, I'm glad to be here. Start my presentation, which is quite related to this moment, because as you can see here, we have on the airports, now they are checking for the few passengers they're getting at the airports, they're checking the temperature with a spatial machine, which is AI, so artificial intelligence, because artificial intelligence, which is what we're going to speak about today, became very much important in our life, in all day life. For example, when we use iPhone, we want to speak with Siri to ask her what time is it, or when we use Alexa from Amazon and we ask her to tell us what's the weather outside. This is all driven by artificial intelligence. So we sometimes use artificial intelligence without knowing it. So today we're going to speak about artificial intelligence in endoscopy. And I'm going to give a brief introduction, then I'm going to explain what is and how artificial intelligence works. And in particular, I'm going to focus on the convolutional neural network. And then we're going to speak about artificial intelligence in upper GI, lower GI, and capsule endoscopy. And finally, we'll have the conclusion. So this is a great book that I've read recently. Has been written by Mr. Dr. Topol, which is a cardiologist who works in the States, and is about artificial intelligence in general and how it can change our daily practice as doctors. But this graph was very important to me because, as you can see, over the last 7 years, 8 years, there has been an explosion of the use of artificial intelligence in outside the medical field, but now even in the medical field. So, believe it or not, artificial intelligence was firstly coined as a name in 1955 by J. McCarthy. And in 1959, the first system called machine learning was described. And in 1997, some of you might remember it, but artificial intelligence beat Kasparov during a chess match. And that was incredible because at that time, Kasparov was considered a genius and was basically unbeaten in chess games. And here I wrote in 2004, there were self-driving vehicles. So it's not Tesla or other vehicles that are novelty, but even in the 90s, there were already self-drive vehicles. And this is thanks to artificial intelligence. But what is artificial intelligence? Artificial intelligence is a term of a branch of computer science that are used to mimic the human cognition for problem solving. And artificial intelligence is a big word that includes machine learning, which is focused on how to make computer work on its own without encoding instruction, which is the classical process for computers, for example. And part of the machine learning is the deep learning, which is very important for us in endoscopy, because deep learning is basically a system that mimics our brain, our convolutional neuronal network, also called CNN. So basically, we have an algorithm that mimic our brains, and in order to use this algorithm, we have to train him first. So this is the first step. So we give the algorithm a lot of data, and during the second step, we'll give to the algorithm, we use the algorithm which has already been trained to do what we ask the algorithm to. For example, this is the classical draw of a very simplified draw of a convolutional neural network of an algorithm. Basically, you have a dog here. You enter this information in the input layer. Then this information is reprocessed in the hidden layer. And then at the end, you have a final output, a final information, which is a dog. So this is how the system works. You gave to the system a lot of information that go through the layers, and then they are reprocessed as a true or false. So if you gave him a cat, maybe it's false, and if you gave a dog, it's true. And so it's the system start little by little to make a differentiate and recognize what a dog is. So when you want to go more specifically and you want to tell, is it a Labrador, is it a white Labrador? So you need to give the algorithm even more information. And you can also, you have to give the algorithm a specific information. So you have to be very precise, because if you give the algorithm this information, it will still recognize that it's a white Labrador. But if you give this one, maybe you won't recognize it because it's on his back, or this one, it won't see his face, or this one is a black Labrador. So it probably categorize this one as a false. So at the end of the day, the algorithm pick a lot of information. We're speaking about thousands of information, and little by little reconstruct what a white Labrador is, a person is, or what a polyp is, depending on how you want to train it. And at the end, the rapidity of how it reprocesses all the information that we give to the algorithm is incredible. It's so fast that a human brain couldn't even go close to it. What was missing to AI to become so important before 2020, 2018, 2016, 2013, which is the date where the explosion started? So one, we needed powerful machines, okay? So powerful computers, which have became available over the last decade. But also the second important thing is that, as you have already understood from my previous slide, you needed a lot of data, a lot of picture of dogs, of Labrador, or a lot of picture of polyps or whatever. So depending on what are you using the algorithm for. And for this, you need the internet, but you need big data, very fast and quick internet connections, but also nowadays becoming even more, even easier, because we are using a lot of social media. And if you think about Instagram or other platform, there is an amount of pictures and photographs that certainly has make this process even easier. In endoscopy, now we pass to the second part of my talk. The AI has become extremely important, especially over the last 2 years. There's been an explosion on publication regarding AI. If you go on PubMed and you type AI gastrointestinal endoscopy, you will find that there are hundreds of publications already. And this is not, it's not by chance that gastrointestinal endoscopy last year launched an open list of topics that they would have prioritized for publication and research, and AI was in the 4th position. But even more interestingly, a few months ago, there was an open call for a GI, gastrointestinal endoscopy, for publication related to endoscopy and AI. So it's becoming a big topic. If it wasn't of COVID, which is now the main topic, AI was for sure the #1 topic in endoscopy. Right, so let's focus a little bit on endoscopy now. So I will briefly touch upper GI endoscopy, lower GI, and capsule endoscopy. Um, so we'll start from Barrett's esophagus, and I will start from this very interesting study done by Hashimoto et al. About the use of AI for detection of early esophageal neoplasia in Barrett's esophagus. So they took almost 2,000 images of the Barrett's esophagus, and what they did was they used 1,300, almost 1,400 images for training the system, as we said before. And once the system was ready and trained with all these images, they gave to the system 458 images to review. And the system was indeed able to reprocess this second set of images. And the results were very interesting because out of almost 500 images, 225 were with dysplasia and 233 were without dysplasia. And the algorithm AI was able to detect the early neoplasia with a sensitivity of 96%, a specificity of 94%, and accuracy of 95%. So we are speaking of a very high accuracy. This is what the system that the Japanese endoscopists used for their studies. So here they pass to MBI. You can see that there is a green circle here, which is indicating the lesion where is dysplasia. And also, if you look, there are some numbers, which is the probability of the dysplasia. And of course, you need to keep it still, to have a still image to increase the chances of being more accurate. Still, for Barrett's esophagus, we have a multi-center study that has been done by the Amsterdam Center, led by the Amsterdam Center, which showed that AI was accurate for 89% accuracy, 90% of sensitivity, and 88% of specificity when distinguished the neoplasm and non-neoplastic for Barrett's esophagus. When AI was compared with not expert endoscopists, then it was superior to the not expert endoscopy, as you can see from the data here. And he had a similar accuracy, sensitivity, and specificity of the expert. So indeed, very interesting and very good results. When we go to early gastric cancer, I selected this specific publication, which was published in Gastric Cancer in 2018, because first of all, the authors did train the algorithm with more than 13,000 images, and they did a validation of with more than 2,000 images of 69 consecutive patients with 77 cancer lesions. So they took more than 2,000 pictures from 77 cancer lesions, so multiple pictures for any for a single cancer. And on the left of the screen, you can see that the yellow boxes are where the AI picked up some cancer and the expert or the endoscopist didn't, because when they had both of them picked up the lesion, we had the green box, which is the one for the endoscopist, and the yellow one, which is for the AI. And sometimes AI was the only one to pick it up, a cancer lesion, and sometimes the endoscopy was the only one to pick it up. But overall, the 71 of 77 gastric cancer lesion were found by AI with a sensitivity of 92%. 161 non-cancerous lesions were detected as gastric cancer by AI. And these indeed showed a very low positive predict value. So AI in this case wasn't able to differentiate cancerous and non-cancerous lesion, which was a limitation, a weakness of AI in this study. But AI picked up 70 out of 71, so 98% of lesion bigger or equal 6 millimeter. There are many studies out there. I selected the one that I thought they were the most important and representative of the potential of AI. For lower GI, for sure, Medtronic with GI Genius is one of the most important and active type of AI recognition of polyps. I think it was the first one to become available on the market. And here you can use the GI Genius and plug it in on any endoscopy stack. And it basically recognizes the polyp with this green box, and then it's up to the endoscopy to check it closer. What is important is now that everyone, for sure, Pentax, Olympus, and Fujifilm have also developed the AI. The Olympus have developed AI and have incorporated AI in the new scope that is coming out very soon. Fujifilm has a new AI machine that will be incorporated in the scopes, and as well as Pentax. So there is a lot of interest also from the companies about AI, and as we'll see later, for capsule endoscopy, both Medtronic and Ancon is working on that as well. What is important in the colonoscopy, as you see from this image, is that you need a very, very clean colon, because if the bowel prep is no good, AI won't help you. And the other thing is, as usual, you need to check to have a good visualization of the colon. What I want to highlight that is important in order to understand, because one of the questions might be, why is AI thought to be helpful for colonoscopists? Because at the end of the day, if we come out with 6 to 10 minutes, we do the withdrawing time during a colonoscopy, we might pick up a lot of polyp anyway. We don't have any study comparing. We have some study comparing that, and we'll see it, and we see that AI have a very good values. But what is important is this. From a neural point of view, our brain and our visual has two main vision peculiarity. One is a peculiar vision. So we focus, and the center, we are focused looking for a polyp, and we leave the rest. So we really check where the scope is going and what is the scope visualizing, okay? And then we have a peripheral neuronal, I would say, a neuronal other kind of layer that help us to also be alert on the peripheral part of the vision, so on the periphery. So, and this is something that comes back from from many years from our origins in human being, because was basically allow us to be alerted when the danger was coming. So even if we were in focus on the lateral side of our eyes, if we catch something moving, we suddenly check what was going on. So we have two main vision. One is the main focus, and one is the peripheral vision. And this is very important because basically many a time the polyps that we miss is because they are not on our main focus, but they are on our peripheral vision. But since they don't move or they don't highlight very fast unless we really see them and we really focus on them, we might miss them. And this is why AI for colonoscopy and for lesion detection might be very helpful, because it might highlight something that is on the peripheral vision, which might otherwise be missed. Saying that, there is this is one of the most important study for lower GI for polyp detection published up to date. It's been done by Wong et al. Was published in Gut in 2019, and basically they did a prospective randomized control study with more than 1,000 patients included. Of these, they had 536 standard colonoscopy and 522 colonoscopy with AI. So the results were amazing because basically the adenoma detection rate increased in the colonoscopy with AI significantly. We had an increase of, with AI, we had 29% of detection rate, adenoma detection rate against 20%, significantly important, significantly difference, and a mean average of polyp per person, of adenoma per person, were as well higher on the AI with colonoscopy compared without AI. And with the colonoscopy with using AI, more diminutive adenomas and more hyperplastic polyp were significantly detected, while there were no difference in larger adenomas. And we can understand why polyps larger, bigger than the 1-2 centimeter are easier to be picked up by the endoscopist. Now, regarding the characterization, rather than focusing on one study, I focus on 3 studies, which came from Professor Kudo's team in Yokohama, who has been always very, as we all know, focused on the characterization of polyp, but also they have published a lot on the use of AI regarding characterization, and they have developed something called endobrain. So they published initially characterization about not invasive and invasive colorectal cancer. Sensitivity was 89%, specificity was 98%, and accuracy 94%, with a very high positive predictive value and 90% of negative predictive value. And this was published in Endoscopy 2017. Following that, they did another study which was characterizing the colorectal lesion using narrowband imaging and NBI. And overall, they had a good specificity and accuracy, but the sensitivity in this case was low. For this reason, they developed a prospective study, which was published in Annals of Internal Medicine, and they showed that the negative predictive value for using AI for diminutive rectal sigmoid adenomas were around 96%. So indeed, very high results. This is what Professor Kudo's team has developed through the years. So they have combined a system where they can both detect the polyp in the colon, and also they can predict the polyp, predict the nature of the polyp. Here we have the endobrain. As you can see, the endobrain start lighting up with yellow when you see a polyp, and then when you go close to the polyp, the system check what the pit pattern is and what are the chances of the polyp to be neoplastic or non-neoplastic, bearing in mind that the Japanese uses slightly different classification for neoplastic and non-neoplastic that we use. So for high-grade dysplasia, for them is neoplastic. For low-grade dysplasia, it's not neoplastic, etc., etc. Okay. Now, what about capsule endoscopy? Capsule endoscopy, initially there wasn't much about capsule endoscopy in AI, but then in this already in the first semester of 2019, there's been an explosion of AI in capsule endoscopy. And the main majority of the studies were performed of still pictures, which is a limitation of the study, because nowadays, majority of the studies are performed on videos when it's possible. And so, and then they replicate on the standard clinical practice. So I will skip all the studies that I have for capsule, but one, which was indeed, to me, revolutionary. In fact, it was published in Gastroenterology in 2019, is a Chinese study. They use Ancon capsule, and basically they included 5,000 patients where they trained the AI with 198,000 images, which is a massive number of cases. And then the AI checked the images and the endoscopy checked the images, and then there was a comparison between the two groups. And what appeared was that the sensitivity between the conventional reading group, or meaning the endoscopist, was 74%, and AI at the 99% sensitivity. And the negative predictive value was 67 for the endoscopist and 99 for AI. And this is, and when the analysis were done per lesion, again, we had similar results. So this is really a change in our usual standard practice. And also because he helped to reduce the time that we use for reading the capsule from almost 2 hours to 6 minutes. And this is a video where I want to show a few things that are very interesting. So this is a capsule. So first of all, here they're not using AI, and you can see that this video contains around 32,000 images, okay? So the blue box are the suspected lesions, suspected abnormalities. Of course, AI, I think, sometimes highlight or even bubbles as seen by previous studies. So even in the small bowel, the preparation is important. So you can see how AI is important. And now when we move forward, we can see when we select only to use AI, so we have one lesion after the other, and the capsule, the length of the capsule is reduced. We go from 2,400 images to only 500 images to reduce. So it is reduced by 1/5. So this is for the people who perform capsule endoscopy, this is a big change in practice, because this in the future might allows us to do more capsule in the same period of time that maybe we use for few capsules. So this is very promising, but of course this needs to be validated by other studies. So in conclusion, CNN is, so artificial intelligence is a reality in endoscopy. Is this the way forward, and will make a difference. It's a revolution if it's effective, and it will have time. We will allow time saving and cost saving, also as already shown in some publication. But there are some ethical concerns because we're still speaking about sensible data, sensible images, confidentiality, etc., and there are also legal implications. CNN has some limits. Someone says that has already reached its maximum development, cannot be developed anymore, and so we need to think about something more for the future. And however, since CNN AI as a learning, it's developed as the brain, sometimes we don't really understand how AI works, as we don't fully understand how our brain works at the time, up to date. I want to finish with a few very interesting sentences about AI. One is the development of AI could spell the end of human race. This is this was said by Stephen Hawkins. And with AI, we are summoning with the demon, and this is Elon Musk, and AI is potentially more dangerous than a nuclear catastrophe. And this is said by Bill Gates. So there are some potential problems with AI, and this is recognized. If this is so dangerous, I'm not sure of. I want to, of course, always thank my team for all the support. And this year, for the COVID, usually we invite you to join us in London from 9 to 11 on September 2020. This year, we're not sure if the masterclass will go ahead, but if not, we will have something as an alternative to offer to all our AEM lovers. Thank you so much.